बिस्मिल्लाहिर्रहमानिर्रहीम रब्बिश शाली सदरी व यस्सिरली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Assalamu alaikum. Today we will do 2.1.3 Circular Polarization from the book Quantum Mechanics by Beck. Now consider the special case of phi is equal to pi over 2 and E naught x is equal to E naught y is equal to E naught under root 2. The polarization vector is then epsilon naught is equal to 1 under root 2 ux plus iota uy. How can we make sense of this complex vector? Remember that to find the real field, we need to take the real part. However, the polarization vector is constant in both time and space, so taking its real part just leaves a constant vector, which yields no information about the oscillations of the field. We need to go back to the real physical, temporally and spatially varying fields described in equation 2.3. With the assumption we are making here, these fields become Ex is equal to E naught over under root 2 cos kz minus omega t. Ey is equal to E naught over under root 2 cos kz minus omega t plus pi over 2. This is equal to minus E naught over under root 2 sin kz minus omega t. These fields are equal amplitude sinusoidally oscillating waves that are phase shifted with respect to each other. To examine how the field oscillates in time in a plane perpendicular to the propagation direction, we set z is equal to 0 and obtain Ex is equal to E naught over under root 2 cos minus omega t. Since cos is an even function, cos minus omega t is equal to cos omega t. Therefore, we obtain E naught over under root 2 cos omega t. Ey is equal to minus E naught over under root 2 sin minus omega t. Since sine is an odd function, sine minus omega t is equal to minus sin omega t, which means that this is equal to E naught over under root 2 sin omega t. Figure 2.2 shows the total electric field vector obtained from equation 2.18 and 2.19 at different times. The time in figure 2.2 is expressed as a fraction of the oscillation period t is equal to 2 pi over omega. The electric field sweeps out a circle as it rotates counterclockwise, so the field is circularly polarized. The field makes one full rotation during each oscillation period t. Circular polarization comes in two flavors, left circular and right circular. Figure 2.2 represents left circularly polarized light. Point your left thumb toward the source into the page and your fingers will curl in the direction of rotation. This convention is exactly opposite to what you might expect. Your thumb must point toward the source, which is opposite the direction of propagation. Figure 2.3 shows a 3D representation of a propagating left circularly polarized wave. Figure 2.2, the direction of the electric field vectors at different times for a left circularly polarized wave that is propagating out of the page. We will point our left thumb into the page that is towards the source and our fingers will curl in the direction of rotation that is counterclockwise or left-handed circularly polarized with respect to the source. I have written this code on Python. If one electric field is cosine and the other electric field is sine, the superposition will give circularly polarized light. In the period of 2 pi, we will obtain a complete circle. In the period of 4 pi, we will obtain 2 circles. In the period of 6 pi, we will obtain 3 circles. If we make both the waves sine such that the phase between them is 0, we will obtain linearly polarized light. If we make both of them cosine and the phase is 0 between them, again we will get linearly polarized light. On the other hand, if one is sine and the other is cosine, we obtain circularly polarized light. A right-handed clockwise circularly polarized wave as defined from the point of view of the source, it would be considered left-handed anti-clockwise circularly polarized if defined from the point of view of the receiver. A left-handed anti-clockwise circularly polarized wave, as defined from the point of view of the source, it would be considered right-handed clockwise circularly polarized if defined from the point of view of the receiver. Thank you for watching. Allah Hafiz.